Hello students, again I am here to explain the second application of Gauss theorem. And what is this? This is the electric field due to thin uniformly charged plane sheet. So for this, firstly we have clear about the surface charge density. What is the surface charge density? First we will discuss it and then we derive the application of Gauss theorem. So what is sigma? Sigma is called here surface charge density. And what is Q? Q is here charge and A is here area. Sigma is defined as charge per unit area. So how we define it and what is the actual meaning of this physical quantity? So suppose that you have any surface area. Suppose that this is your surface area, and area of this surface is suppose that 2 meters square, and we consider here total charge is distributed like suppose that 20 coulomb. So as you know that for 2 meters square area, charge is distributed how much? 20 coulomb. Suppose that we have find out for 1 meter square. So charge is distributed for 1 meter square is 20 divided by 2. It means that 10 coulomb per meter square. So what is the actual meaning of surface charge density? It gives a real view that for 1 meter square, how much? For 1 meter square, how much charge is distributed on the surface? So it gives an idea for 1 meter square charge distributed on a surface, and suppose that surface charge density is equal to 2 coulomb per meter square, and we have to calculate total charge for area 20 meter square. Suppose that this is you have a question. Sigma is a charge density that is given 2 coulomb per meter square, and you have to calculate charge distribution for area 20 meter square. So how you calculate? Surface charge density give the idea for 1 meter square, and here we calculate for 20 meter square. So what is the formula of charge? Calculating from the charge density is the sigma into area, and write down the value of sigma. Sigma is here 2 coulomb per meter square and area is here 20, so you have to write 40 coulomb. So sigma is what? Sigma given a rough idea the charge distribution on a unit meter square area. Okay, now what is the unit of this surface charge density? It is coulomb per meter square. Now our topic is what? Electric field due to a thin uniformly charged plane sheet. Suppose that you take a plane sheet and it have positive charge distribution, and its surface charge density is sigma plus sigma. Okay. For applying the Gauss theorem, we have to choose here Gaussian surface. So choose here Gaussian surface, a cylindrical Gaussian surface having cross section area A and length L. As you saw that as you seen in the figure, what happened? The electric field due to positive charge is always outward. It's just always outward, and this is a just thin charge sheet. So we have to take only positive charge on the sheet. So due to positive charge sheet, electric field is just outward. Next, here we choose cylindrical Gaussian surface. So it have 3 type of area. 2 are circular shape and 1 is curved surface. So for 3 surfaces, here we find out the angle between the area vector and electric field. For this, in this region, electric field is just outward, and area vector is always perpendicular to the plane. So its area vector is just all along the direction of electric field. For this area, as we have discussed, electric field is just outward, and for this area is for this plane, area vector is always perpendicular to the surface, or you can say it is parallel to the electric field. But for curved surface area, area vector for curved surface area is just right angle to the electric field, because electric field in along x direction and the area vector is along y direction, and between x and y axis there is a 90-degree angle. So first you have mentioned here ds1 area of first surface parallel to the electric field, area of second surface parallel to the electric field, and area for curved surface is perpendicular to the electric field. First we have calculate electric flux manually and then apply the formula. Electric field vector dot area vector. What is the meaning of this circle? The meaning of this circle gives the total electric flux covering all the surfaces over closed surface, not for a particular surface, for closest figure. Divide this portion in three parts: area vector S1, S2 and S3. So you have to write here electric field vector dot ds1 vector, electric field vector dot ds2 vector, electric field vector dot ds3 vector. Here you take the sign of integration like this. As we have already discussed here, these two are parallel and one is perpendicular. For parallel we have write here angle cos 0. Here is also cos 0, and for perpendicular we have write cos 90. For cos 90, the value of cos 90 is always 0 and cos 0 is equal to 1, cos 0 is equal to 1, and take out the electric field just outside. And as we have already mentioned here that circular surface have area A, and in slender both surface having the same area, so it is also suppose that area A. So here write total area of ds1 surface and total area of ds2 surface, EA and EA. Flux is equal to what? 2EA. Write down, this is the first equation. Now according to Gauss theorem, flux is given by total charge enclosed in a surface area, closed surface area, divided by epsilon naught. And I have already discussed what is the sigma. Sigma is equal to Q divided by A. So write the charge in the form of surface charge density sigma into A divided by epsilon naught. Write down the equation number 2. From equation number 1 and equation number 2 we get 2EA is equal to sigma A divided by epsilon naught. So area, cancel the area both sides, and we calculate here electric field is equal to sigma divided by 2 epsilon naught. Now how we find the dependence of electric field on distance from the surface charge distribution. Suppose that you have this thin charge sheet, and we have to calculate electric field at distance r1 and then distance at r2. This is for r1, and at this point suppose that p1, and this point suppose that p2. So we have to calculate the electric field at point p1 and p2. But what happened in the formula? There is no dependence of electric field on the r. It depend only surface charge density and sigma. This is also a constant, and for a charge distribution it is also a constant. So it means that at point P1 and point P2 electric field is remain constant, or you can write here sigma electric field for one point is equal to electric field for second point is equal to sigma divided by 2 epsilon naught. So what is the graph between electric field versus distance from the surface charge distribution thin charge sheet? So it gives a straight line. It means that for any point, as you increase the distance, electric field remain constant at every point. It means that electric field does not depend on the r. So graph between electric field and distance r is just straight line. Now there are some cases for the surface charge distribution. Here we consider two plane sheet, and both are having the surface charge distribution and having the charge density sigma. Suppose that this one is sigma 1 and this one is sigma 2, and this one also having the positive charge distribution. Students are doing some mistakes to find out the direction of electric field. For these two plates, there are three regions. One region is between these two plates, another one is left side, and another one is right side. So you have to write here, this one is the first region, this one is your second region, and this one is your third region, right? Now first you put the direction of electric field here. Suppose that here we take the direction r unit vector in this direction. We have defined a unit vector in this direction. It means in this direction all the quantity is taken as positive, and in this just opposite to this direction all the quantity is taken as negative. Just define yourself as a direction unit vector. Okay. So first we have to find the direction of electric field in between the region, means first region. What happened in the first region? Suppose that for first region, suppose that this is not keep here. If this one is not keep here, then what is the direction of electric field due to this sheet? For this, electric field due to positive charge is always outward. Put the arrow in the direction of electric field and write down here E1 because it has surface charge density sigma 1. Okay. Now for find out the direction of electric field due to this sheet in this region, suppose that this one is not present here. If this one is not present here, electric field is due to only this portion, and you know very well electric field due to positive charge is just always outward. So what is the direction of electric field due to this region? E, write down here E2 because it have a surface charge density sigma 2. So write down here for region 1, net electric field is given by E1 plus E2. Put the value of electric field. You know very well electric field due to a thin sheet is given by sigma by 2 epsilon naught. For E1 we take the surface charge density for this surface, and for E2 we take the surface charge density of this surface sigma 2. So sigma 1 divided by epsilon naught. Electric field is a vector quantity. So to find the direction of electric field, we have already supposed that a unit vector, the direction taken in the direction of unit vector is taken as positive, and direction is just opposite to this vector is taken as negative. This E1 and this R unit vector is just in the same direction, so you have right here plus sigma 1 by epsilon 2 epsilon naught. And for electric field due to second surface, direction of this electric field is just opposite to the unit vector, so you have to write here minus sigma 2 divided by 2 epsilon naught. So take out the some common term, 1 by 2 epsilon naught, here sigma 1 minus sigma 2. Next one we take region second. For region second, suppose that this one is not present here, so electric field due to this thin sheet is just outward. So write down here E1. For next case, suppose that this region is not, this charge is not present here. So due to this surface charge distribution, electric field is just always outward. So draw the direction of electric field. This is E2. Now calculate the electric field in region. Which region? Second region. So you have to write here electric field is equal to E1 plus E2. Now you can easily observe that direction of this electric field is just opposite to the unit vector. So you have to write here, and you also mention here unit vector. Now write down the sigma 1 divided by 2 epsilon naught R unit vector, and direction of electric field is just opposite to the unit vector, so write down here negative sign. Then minus sigma 2 divided by 2 epsilon naught R unit vector. So what is the formula? What is the net formula for this? Take out the some common term, minus sigma 1 minus sigma 2 and R unit vector. And what are the changes for this region? Again, you suppose that at one time one sheet is present here. If you are supposing that only this seat is present, and due to this seat electric field is just outward. It means write down here direction electric field E1. And next case, suppose that this region is present only, so due to this region electric field is also again outward. It means that this one is E2. How we calculate the electric field in region third? Write down that net electric field is equal to E1 plus E2. Both electric field have the direction just similar to the direction of unit vector. So write down here sigma 1 divided by 2 epsilon naught r unit vector, sigma 2 divided by 2 epsilon naught r unit vector. So take some term common, 2 epsilon naught, sigma 1 plus sigma 2 r unit vector. Hope so you are like this video. If you are really like this video, then please comment and share and subscribe. Thank you.